Hello, today I'm going to talk to you about Axelar. So what exactly is Axelar? So as I put on the previous page, I say that Axelar is a translator for the blockchain verse. Axelar primary goals are to solve the cross-chain problem and promote the interoperability through the use of a decentralized network. Okay, couple of big words in there. What is a cross-chain? And what is the problem? And what exactly does the term interoperability mean? Okay, that is a little bit easier. Interoperability refers to the ability of different things to communicate with one another. The internet is a very good example of this. As you can see, many different types of equipments and web servers, they can interact with one another. When you visit a website, you are essentially connecting to the server. On the other hand, there are currently many different chains on blockchain ecosystem. But the communication or the transferring of information between them is extremely difficult. Let's break it down by looking at a basic description of blockchain and where the apps or the decentralized applications are located. The blockchain ecosystem can be thought of as several layers built on top of one another. On the most fundamental level, there is the chain itself. It is made up of blocks that contain information that are chained together. Hence the name blockchain. The block's validity or correctness is verified by a group of people known as the validators, who adhere to a certain set of rules or protocols. This is to reach an agreement or consensus among the validators, even if there is an evil validator who tries to throw people off track. Finally, the validators allow the chain to continue operating even if they do not determine the chain's future or direction. We can think of a chain as a country. Let's say the USA, okay, the United States. The validators are the senator in the parliament. The validators are the senators in parliament who vote on any proposed legislation. They must follow a specific rule or protocol. For example, the vote must exceed a certain threshold for a bill to pass or a consensus to be reached. The new law will be added to the Constitution's existing one, just like the new block is added to the chain. On a slightly higher level, each chain has a native token that serves as the basic fare for any transaction performed on that chain. For example, the Ethereum chain employs ETH and the United States employs the US dollar as its native currency. DApps or decentralized applications are built on the foundation of chain and work on smart contracts, which are a set of code or manual for how the app is supposed to operate. They may be multiple DApps on the same chain, but their smart contracts may differ. DApps can be thought of as businesses. There may be several companies based in the same country. Each company has its own set of rules and visions, but those rules must be consistent with the Constitution. So the rule of the business, the rule of each company is like the smart contract. Each chain has a unique fundamental structure which limits the capabilities of the apps built on it. As a result, some DApps may require a very high transaction per second or a very low transaction fee to be viable. The DApps developers will have to select an appropriate chain to deploy their apps on. In comparison, it is easy to imagine that the two countries' building codes are dissimilar. The first country does not impose any restrictions, whereas the second one requires the building to be no taller than a certain height. You can see that these buildings are quite short. If an entrepreneur wants to construct a large grand building for his office, he will be unable to do so in the second country. This is not to say that the second country is without any merit. Perhaps there is something else that works particularly well for it. Each DApp generates one or more tokens that can be used to access specific services. The tokens can only be used in the native app, but it may be accepted by other apps on occasions. It's as if a company gives its customer a coupons that can be redeemed for services. A frozen yogurt company, for example, gives the customer one coupon per purchase. If 10 coupons are collected, they can be redeemed at the original company for one free yogurt. Another partner company may offer another deal. Customers can use the first company coupon to get a discount at the second company. On the top level, we have the users. They can interact with the apps by move token in and out of their wallet. As long as they have the supported wallet, they are free to interact with any DApp. It's the same as customer in a country being able to walk in and out of any businesses. So this person might deal with this one, he could go to there, he could go to there. So that is the ecosystem of the blockchain. There are currently tens, if not hundreds, of chains in operation. Each has its own set of rules, abilities, and limitations. The chain's connection is virtually non-existent. This causes issues for two groups of people, the developers and the users. For example, suppose a DApp is deployed on one chain that is compatible with the app. So that company is built on that chain, which works well. But the developer wishes to expand the user base to those on another chain. Due to the different fundamental structures of the chain, they can't simply pop the same structure onto another chain. Users on another chain also want to invest, want to interact with the company, but there is no way to transfer the funds across. This is known as the cross-chain problem. How is it to be resolved? One method is for the developers to build a bridge specifically for their user to a specific chain. Of course, this is extremely costly solution. Worse, it's not scalable, which means that if the developers want to expand to the third chain, they will have to build another bridge from scratch. Unscalable. This is not what we want. We want the developers to focus on what they do best, creating the apps. They should not spend their time and effort and resources to study and creating these bridges. Let's consider some of the current workarounds for asset transfer across chains, as well as their drawbacks. This is primarily how users transfer funds from one location to another. The first is centralized system. This is currently the only truly scalable solution. So the user provides the fund to the centralized agency, then the user can withdraw their fund out onto another chain. The centralized system can incorporate any asset or any chain relatively easily and quickly. So for example, there might be a third chain, so the centralized can drop that asset onto that third chain quite easily. The problem, and it's a big one, is that they are centralized. It is required to have faith in the centralized agency to do their jobs properly. The second one, interoperability hubs. Cosmos, Polkadot, and Avalanche are examples of chains with similar foundations or structures, making connections between them simple. As shown in the diagram, the building on these chains are quite tall, whereas the building on another chains are significantly shorter. This is because all buildings or dApps on the same hub must follow the same rules. It does resolve a local cross-chain problem. So information can transfer locally, but the problem is that the interoperability exists only among the chains in the same group. Moving assets across these hubs remains challenging. Furthermore, if a new chain wishes to join, it must follow the same structure or protocol as the rest of the group. So it is still unscalable. The third option is pairwise bridges. This is a bridge designed specifically for a selected set of chains for a particular asset. This necessitates a significant engineering effort on the part of developers as they must apprehend the logic of smart contracts on both chains. Furthermore, if one of the chain protocols is updated, the existing bridge must be updated as well. It requires constant maintenance. The most serious issue is that it's completely unscalable. If the developers want to build a bridge to the third chain, they must start from scratch. Furthermore, if a bridge connects A to B, and another bridge connects A to C, there is no guarantee that everything will work if an asset is transferred from B to C via A. So how will Axelar solve the problem? The Axelar network is made up of two protocols that operate on two different levels. It serves as a universal hub for any existing or future chain. A threshold account depicted as the gateway in this diagram is required for a chain to be connected to Axelar network. Okay, so the threshold account. This makes Axelar quite scalable because if we want to connect the third chain with this, all we need to do is construct one threshold account on there and then we can connect it to Axelar. Once the threshold account is there, everything is ready to go. Every dApp on the chain can interact with Axelar through that gate. The following are three important aspects of Axelar. 1. Cross-chain Gateway Protocol, or CGP, is built on the chain layer. In this picture, it's this orange pathway. The primary function is to route data from one chain to another. The information could be anything from the interest rate of a pool in one chain to the block number or the number of tokens in a specific wallet. So CGP is the chain level that connecting in between the two different chains. 2. Cross-chain Transfer Protocol, or CTP. In this picture, we are talking about these people. CTP. CTP is built on the dApp levels. The primary function is for dApps to interact with Axelar and send requests to it. Imagine it as a courier running in between the dApp and Axelar, transporting requests and information. So he is going to be running there, running back, running there, running back. The third one is threshold signature. It is a security measure used by Axelar validators to validate transactions. Consider splitting a key to a specific door into many tiny pieces and handing it to validators. Okay, so each tiny pieces are given to each validators. A single validator will not have enough information about the key to open the door. A true key can be forged only after a certain number of validators come together and combine their key fragments. Let's see how the problem posted before can be resolved using Axelar. The first one is asset transfer. If a user wishes to move an asset from one chain to another chain, he or she can communicate with Axelar via CTP. So he contact with the CTP to tell Axelar that he wants to move the asset across. So the step would be like this. 1, 2 threshold wallets will be generated, one for each chain. Axelar will provide the user with the addresses for these 2 wallets. 2, the user deposit his asset into the wallet on the original chain. 3, the Axelar CGP. Okay, the Axelar CGP network verifies that the asset is indeed in the wallet. If yes, the user is permitted to withdraw the asset from the destination chain wallet. It should be noted that the asset taken out by the user is not the original token that is locked inside the wallet, but rather another token that is pegged to the first one. The original token is now locked and cannot be used by anyone unless the user returns the pegged token. Don't worry if this seems too difficult, just know that the user can now move the asset across chains. In the grand scheme of things, the process is very similar to transferring assets through centralized system, but Axelar is decentralized. Since the 2 generated wallets are threshold wallet, the locking, unlocking, and withdrawal of funds must be verified by a certain number of validators. This safeguards the process against malicious attempts. The second scenario could be the dApps that want to expand their user base. The procedure can be carried out as follows. 1. The dApp communicates with Axelar via CTP to create a threshold account on another chain. The user on another chain places the asset into the designated wallet. So Axelar CGP check if the asset were actually in the wallet. If this is the case, the dApps can issue the rewards to the user. So the user can start reap the benefits of investing without having to move the asset across chains. What Axelar can do doesn't stop with just these 2 examples. Axelar can be used to do the following task. The first task is query the information. For example, a dApp on one chain might want to check the interest rate given out by another dApp on another chain. So this red dApp could interact with CTP and the information route through the CGP go to check. Let's say the interest is 15%, coming back, the data is routing back through CGP and then given back to our red app. So the red app might react by increase its own reward. Second one, a user wants to exchange one token for another instead of confined to the exchange rate quoted by the app in one chain. The user can find the best rate from the apps in all the chains that are connected to the Axelar. So he is like yelling, who can give me the best rate? And it might be the app on another chain that's like, yeah, I can give you this better rate. So same thing, the fund could be transferred to there, makes the exchange, and then coming back. So the user will have a better experience that he doesn't need to cross the chain himself. The third one is, let's say a user wants to buy an NFT which is hosted on another chain. The user can pay for it using any token from any chain. So he can send this across through Axelar as well. So in the end, Axelar is going to be a central hub where any information, the tokens, the assets can transfer from one chain to another chain seamlessly. So who will benefit from this? 1. The blockchain platform developers. So let's say someone wants to generate a new blockchain. Now, he can just focus on what that blockchain is supposed to be doing well. And he can worry about connecting with the other blockchains through Axelar. 2. The developers. So the dApps developers that want to build the apps, he can just choose the chain that fit the apps the best and just host the apps there. And then he can gain the user base from any other chains through Axelar. 3, of course, is the user. The user now can access the assets, they can move the funds, you can get the information from any chains very quickly. So that's why Axelar is going to be providing the interoperability solution to the cross-chain problems.